Okay, guys, if I can have your attention, my friends, I know you guys are printing things for Chad and what's not. We do have our friend Keith Severson, and Keith is an expert in the low voltage, and he'll talk a little bit more details about the low voltage stuff. And he's here to talk in particular about lighting control systems, low voltage lighting control system, and he has some gadgets he want to show you. So I would hope you guys will give him your full undivided attention. And for that, every one of you guys will get 5 extra points. But that's a pride part. Is that good deal? But out of what? None of you guys ask me out of what. Five could be 5 out of 1 million. Five out of what? Always ask. Okay, go ahead, Keith.
Okay, as Chad said, I'm just going to move a little closer because it's nice and all through. We're local manufacturers, right? My company is the name of the last one says for about a little over 50 years in the electrical business. We focus 100% on lighting and controls. That's all we do. We don't sell switchgear, we don't sell widgets, all that other neat stuff. Completely focused on lighting and controls. And people that are involved in the business will say, how can you possibly make a living? I don't look around. It's everywhere. What we do is involved in every single business. I started doing this with this firm about 25 years ago, which means that probably before some of you were born, which is awesome, makes me feel great. The controls world has changed dramatically. In the olden days, and I love this room because we used to do that, the wall of shame, right? We put a 6-gang box, roughed into a block wall, and we had line voltage switches, and that's what you did. And you put signs, and I saw signs on some of the doors, last one I'll turn off the lights, right? That was light control. That's really what we did because there really wasn't anything else at that point. Code requirements, energy power density requirements have changed. New ASHRAE, if you've introduced a new ASHRAE, it's coming. Yeah, it's not been adopted yet in Minnesota, but it will be. It's supposed to have been done this year. And Minnesota and about 49 other states all said, yeah, we're not ready, so it didn't get adopted, but it will, and that's going to squeeze power density and squeeze controls even tighter as to what has to be designed into the core operating process of the building. So lighting controls always starts at the very base level with the relay. The company I'm going to talk about is Douglas Lighting Controls. I'm not here to pitch Douglas Lighting Controls. But because controls are so specific to the manufacturer, it's hard to talk about it in a broad base. All of us do different things. So Douglas does things differently than other manufacturers. We use a 2-wire data line. Other folks try to use a Cat5 or a Cat5e wiring solution. We didn't follow that belief because we don't think contractors like to terminate Cat5, especially if there's a couple hundred switches in a school. Terminating all that Cat5 just leads to other issues. We work off of a different 2-wire system. But for the very basic process or product in the system is a relay. So Douglas is a Canadian company out of Vancouver. They use a Panasonic relay. The relay, single pole relay, is a full 20 amp rated at 347 volts. Very, very robust, right? We've represented these guys for almost 20 years now. If I've had 10 relays fail in 20 years, that's a lot. And literally, I'm telling you, we have millions of these relays in the market. So the relay doesn't fail on purpose. And you can use different relays. I mean, a relay is a relay, right? It's just a contact closure, right? The relay was designed very specifically for lighting because of the high inrush in lighting. And there's an inrush current when you turn on your fluorescent lamps. There's an inrush current, right? And that has to be dealt with. And when Douglas started looking at how to build the relay, they very purposely did some things. One of the first things they did, and we cut away this site so that you can see, okay, let's take a look at it. Number one, you can switch the relay at the relay. Okay? Other folks use an ice cube relay, right? A little white cube that ties in. You don't even really see how the thing wires in. It sits on a printed circuit board. You can't switch that relay any other way other than electronic. Right? You have to have an input device to switch the relay. To us, that doesn't make sense. In construction, it doesn't make sense, right? Because I haven't terminated any switches. So if I want to use the relay control system as my switching device as I'm going through construction, and I haven't devised out the job, not being able to switch the relay after relay doesn't make any sense. So we purposely stay away from that. When you look at the relay itself, you'll see how robust the contact is. Our contact is quite honestly larger than some relays that are being used by other manufacturers. Not that what they're doing is wrong, it's just not the way that we look at it. The other thing we do is the relay, when it closes, right, if it closes like this, that inrush will cause an arc, and that arc will cause contacts to melt. And when those contacts melt, what happens is it closes and welds into a closed position, never to open again. So now you've lost the relay. We purposely, because we know that we're switching high inrush loads, and whether it's fluorescent loads or what's going to be exclusive in the market very, very soon, is LED loads. And LED loads also have real high inrush, right? That we know we can't get away from the inrush, so we have to be able to deal with it on a very basic level, and that's at the relay itself. So when we close that relay, the relay actually sweeps. It doesn't close this way, it closes this way, and you see that when you look at it. That sweep always cleans the contact. Always make sure that we've got a good clean contact, and we're not building carpet or anything else up on the contacts themselves. Also built in, when you take a look inside the relay, you'll see a really, really tiny wire. That little tiny wire in there makes a big difference for us. Like I said, everybody does this differently. And there's digital ways to do this, there's analog ways to do this. We happen to be able to use both digital and analog from a control standpoint. So if I was going to take all those switches out and put a low voltage system in, I could hang a digital switch on the line. I could also hang an analog switch on the line. Okay. If I'm hanging an analog switch on the line, for us, a 3-button station requires 4 wires, 3 hots and a common. Okay. For other manufacturers, they require a hot and common per switch, plus a common for the station. So my 4-wire station is a 7-wire station, right? If you're a contractor, terminating 7 times versus terminating 4 times is a big deal, but there are 150 switches in the space, right? that little bitty wire that you see in there, that little tiny piece of whatever gauge that is, does a lot for us, and that lets us have indication of the switch as well. Whether I want it or not doesn't matter, but I have the capability, because of that little wire, I have indication of the switch. So if I've got a switch here controlling something wherever, I can look at the switch and know whether it's on or off without pulling an additional wire. So back to that same 3-button station, I've got 4 wires, other people have 7 wires. If they want indication, they pull another wire per switch. So now the 7 becomes 10. Right? So from a construction standpoint, it really turns into a big, big deal. And unfortunately, because everybody does this different, when we're in a bid situation against competition, contractors really have no clue. They don't know how many terminations they're doing. If they're lucky enough to get us, and we happen to be low in the project, it's a win for them. If they know us and they buy somebody else's system, it could be a big lose for them, depending on how many terminations they're doing. So that's the basic device. We also do something different. A lot of our competition have stepped up and are using this Panasonic relay now. There's another little section of the code that requires that the relay have the same or higher SCCR rating as the breaker that feeds it. So if your breaker is 10,000 amps, you have to have an SCCR rating of 10,000 amps to add the relay. Okay? So people use these little tiny ice cube relays with contact points that are about the size of a pinhead. They'll tell you that relay, because the code doesn't say the relay has to have it. You can include impedance in the wire. Okay? That makes sense, because through that impedance, I can absorb some of that. That's great in theory, except in reality, when you build a building, you have a light panel, LP1 sits right here. LCP1, light control panel 1, sits right next to it. There's a 3-inch ripple in between them. That's how close they are. So where are we going to put that 40 feet of wire? Well, we're not going to see the big of the coil, right? It's not going to happen. So you can't get that impedance unless you physically remote the relay panel, and nobody wants to remote the relay panel. It's far too much work on the contractor side. So it doesn't make any sense. It's a poor way to get around it. Not every inspector is enforcing it. Some inspectors do, and they're becoming a lot more in tune with that requirement. Because what happens if you don't, and obviously what happens if you don't, you blow that relay, literally blow that relay right out of the pin. Right? If you get a short across that line, and it gets through the circuit breaker, and your device is rated at whatever 2,000 amps, and it just saw 8,000. We all know what's going to happen. It's literally going to blow up, right? Which is the purpose for the rewrite of the code. Enforcement is the next step in that process. So the other thing that we do very purposely, because we know we're switching big lighting loads, and when I say big lighting loads, we are the low voltage control system at the Twin State. Every light fixture in the entire space is controlled by us. Some are controlled as a single pole 120 or 277. Some are controlled as a two pole 480 volt. Okay, for all the right reasons. You can downsize wire conduit, all those other things change. So we use a two pole relay anytime that we can, and almost exclusively outdoors or in large industrial spaces. So this relay has the same properties as this one, and what we do different in a true two-pole relay, if you notice, it's a single throw, just like a two-pole breaker is a single throw breaker, right? And that's on purpose. In programming, I could program one pole hot, one pole not, right? I could make a mistake, and because this is a space on a board, and this is a space on a board, I could program this to have this hot and this not, right? And through programming, I could say, oh, I switched that half, and I could pull somebody right off the ladder because he's taking 20 volts to grounding, him being the ground behind the truck, right? And so we very purposely designed a two-pole relay that mimics a two-pole breaker. We can't make a mistake. If I program one pole or the other pole to go off, the relay has to shut off. It can't not. The relay is also true status all the time. So again, back to that ice cube relay that I can't switch. I also don't know if it's hot or not. The only way to know whether what it's feeding is on or off is to physically be in space, because I can't look at the relay and know. Our relay is true status, has to be true status. It's part of the lever, right? If the contacts are closed, the relay says on. If the contacts are open, the relay says off. It can't be any other way. There's no way that we can program it incorrectly. All that is very much on purpose. So go ahead and take a look at those guys and switch them. So when we do lighting control, there's several different strategies that you have to look at. And one of the things that when we get involved is talking directly with the owner about who's going to maintain the system. If it's a one-up building and their guy's job is fixing pumps and motors and all kinds of stuff, this lighting control system is, in his opinion, not a necessary evil, something he has to have, right? Because code requires it, and he wants the simplest system he can possibly get. Right? That's perfectly fine. We have devices that do that. And one of those devices is a guy like this. So I take a time clock photocell interface, and I tie this to a photocell that mounts up on the roof. Photocell is actually a foot candle meter that lets me read real foot candle levels. You better switch up there, keepers. This lets me program on-off sweeps for, or we can switch the interior as well, and we've done the interior as well from an exterior photocell, because again, I'm reading real foot candles. So if I'm going to do daylight harvesting, I can do that with an external photocell, or I can put a photocell inside the space and switch from there as well. But this device lets me, if we just talk about the outside for now, this lets me switch by time, by Astro, right? I can go in and tell this my zip code, and it's just on screen, right? This is meant to hang on the dimmer outside the relay panel. All the programming is done at the relay panel. So I walk in, I activate the device, I tell it where I am, I tell it what time it is right now. It stores that information, and now I've got an Astro-enabled time. Takes care of daylight savings, knows all the holidays, knows everything about you just by telling you what zip code you have, right? So that gives us all kinds of flexibility in switching exterior lighting. As end users are getting more in tune with energy savings, they understand that they have building mounted lighting, they've got site lighting, they've got signage, right? They've got landscape lighting. They have all kinds of things going on outside, because they all need to be on from dark till dawn, right? Does some want to be on before dark? Sure, their signage wants to be on before dark. Maybe the building mounted on before dark. Maybe the lot lighting on a half hour before dark. So by telling it by giving it an Astro enable function, we can then do an offset to Astro. So I can do an offset of 30 minutes or sign just by assigning it to a relay. So I've got two relays feeding all their sign on it. And I can put an Astro enable on it and have that start an hour before dark, and that'll just track through the year, right? Right now is a great time to talk about it because right now it's dark at where the sun sets about 5:30, right? We can do that on at 4:30. In the summer, that on is just going to follow because I'm just following sunset, right? So that on for the sign is just going to happen at 8:30. Okay, so 5:30. All that designed to try to save the owner money. When ASHRAE gets adopted, there'll be certain things that happen outdoors that the owner can't deal with any other way. One of the big keys in outdoor lighting from the owner standpoint is that, and they've changed the wording a couple of different times, but the wording basically says that a half hour after business closed or at curfew. I don't know why curfew matters, but that's part of that's one of the words that they use in it. You have to be able to shut your parking lot lighting off by 50% and maintain uniformity. And we'll come back to that when we talk about a different product. Which makes basically you can't do exterior lighting using HID sources anymore. You can't meet both of those requirements with HID because you can't get the uniformity. So you have to step into an LED type product that lets me switch the fixture in half, right? Because switching HID to a half output level is really not effective. We've tried it. Everybody's tried it. It's failed miserably. You can maybe hold the arc for a while, but then if there's a little bit of voltage dip on the line, the arc extinguishes, and you try to restrike it at the half level or a half power level, it won't restrike, and it's just self-defeating. It chews up the lamp and it burns up the ballast, and then the igniter fails, and it becomes a nightmare. So it's never worked, but it does not work with LED. So when I said LED is taking it over, LED will absolutely dominate, and the new ASHRAE is going to force people to use LED. It's the right thing for them. It's the right thing for the economy. I can take a 400 watt mil halide fixture, right, which draws at 465 watts with ballast losses, and replace it. Simple rule of thumb, about 50% of the power using an LED. So if I got 465 watts of HID load, I can just about replace that with 200 watts of LED load. And then I can switch and multi-switch and do all kinds of nice stuff, dim it. Right? You can do max style dimming, 0 to 10 volt, and all kinds of stuff with LED that you can't do with an HID. So all that stuff comes into play, and ASHRAE is going to require. So this simple device lets me do all those different things, whether I'm tying it to a time clock, or Astro, or tying it to a photo cell, or a combination of. I could do an Astro on and a photo off, or a photo on and an Astro off, or on by Astro and off by time. Any combination of those things can be done. So it's really a question of understanding how the building is used. So we take this simple device, I've got a simple standalone panel. I'll show you how to build some of these risers. Take a little more complicated building, a building with maybe 2 different risers or 2 wings, so I've got 2 separate feeds. This little data card plugs in, snaps right onto the DIN rail. All of this stuff is DIN rail. I'm going to snap it onto the DIN rail, I plug it into a time clock, and I take a pair of 18 tubes, and I tie this panel to the adjacent panel by a twisted pair of 18 tubes, non-shielded, nothing special, bell wire for all purposes, right? We don't even call it a Belden number anymore. This next to that panel lets me do the same thing in panel 2 that I'm doing in panel 1 without having a second redundant panel. All my programming gets to be done in one panel at that point. We've done this for years and years. It's been very, very effective. And we've done huge schools using exactly this system. We've done some of the massive $30, $40, $50 million schools using a system like this where the programming is done at the panel. Because that was the sophistication level that the customer had, right? And you always try to work with what the customer's capabilities are and how they're going to maintain their buildings. And then, fast forward about 18 months because everything changes. It's about an 18-month cycle right now, and then everything turns. Building owners have gotten far more sophisticated. Even some of these small standalone buildings become very sophisticated. Their HVAC systems become very sophisticated using building management systems. And they're understanding that their cost of ownership of that building is all revolving around the power. Lighting being one of the primary problems and HVAC being the secondary problem. So they become very in tune, and so now that building that 5 years ago we would design, I'll call it dumbed down, but not to be derogatory, but we would dumb the building down because that's how the building was going to be. Very little changes, right? This is what it is. It's a store. How it's going to be a store, right? It's never going to be a library. So it's going to be what it is. At this time, it's going to be pretty much set. Set up the days, let the thing run, and the building will run itself. That's changing. So those guys that didn't have a lot of sophistication and controls before, now they do. And they're getting very, very sophisticated. And I've got an owner who and maybe he has multiple buildings, whether it's sitting in Minneapolis or Hennepin County or places like that. They look at it and say, that's great. I'm going to shrink that force. I'm going to shrink those number of eyes. I'm not going to have one guy in every single building who owns that building. I'm going to have a guy that specializes in HVAC and a guy that specializes in electrical. Maybe I combine the two because some of these guys are really, really bright. They've been through good programs. They understand things. But I don't want to make that guy have to go to that building to deal with it. Right? Doesn't make any sense. He's over here doing what he does, and we want to make a change over there. Does he have to drive across town to make that change? Yeah, in the olden days, yeah. Again, the olden days is 5 years ago. It's all relatively new. So we take a device like this, and we can retrofit this into an existing panel. This guy hangs on the same DIN rail that these guys hang on, right? We bring this in, and we bring the internet to it. It has its own IP address. Now I can address this from any place in the world. If I have internet access on my smartphone, I can access this device.
Do you have to do that through a secure portal?
Depending on the owner. Really depends on the owner. Schools, counties, places like that, you typically, I would have to access through it. If I'm going to access it externally, I would access and have to get permission from them. And we do that quite often, right? Once their people are trained, they'll have that access code as part of their setup, right? So they'll just say these out. One guy has 5 buildings in his group that he's maintaining. He'll have the IP addresses already saved into the system so that he knows that Washburn Library has this IP address, right? So he just goes into his laptop, accesses Washburn Library, brings up our whole relay panel schedule. Everything sits on that relay panel schedule, and he can access it via the web. So it doesn't matter where he is. He can be at home in his underwear. It really doesn't make any difference, right? As long as he has web access, he can access it and make all those changes. Huge benefit to owners. This is the way that this is the future. I mean, this is how it's going to be done. And so, like I said before, we would look at these buildings and do simple onboard controls. We still do that. We do a ton of it. We build a little guy like this called a night pack. You know, some guys call it a peanut panel, right? It's a I just grabbed a couple of these. Let me take a quick peek. This is look at that 4. There are, so that's a little peanut panel, right? 8 relays or 16 relays. We can tie them together. We can still do all the Astro, photocell, all of that stuff in it, but what that's really designed to do is replace a 8-pole contactor and a time clock and a photocell, right? And that's not unusual. You guys have seen them here. I'm sure you've talked about lighting contactors, right? An 8-pole lighting contactor really is 2 4-pole devices, right? So if on that 8-pole contactor, if I lose 1 pole on one side, I lose all 4. Right? All 4 of my outputs are gone. I have to replace that whole contactor. With a relay panel, if I blow a relay out, I've got 1 relay fail out of 8. So 7 of my zones are still operating properly versus 4. The footprint on the wall is a lot smaller. Everything lives inside of one. I don't have a separate contactor. I don't have a separate Paragon time clock. I don't have any of that stuff. Everything just lives in one panel. Really simple, straightforward stuff. And we do these for small standalone one-up stores, a standalone store in a parking lot, right? That's going to be a jewelry. It's a jewelry store now. It's going to be a jewelry store until it goes under. And when it comes back up as a Brugger's Bagels, it's still going to be a Brugger's Bagel, right? And because it isn't going to get a bigger footprint, right? And their control scheme is very straightforward. And we can tie switches and all that other stuff to it. So it functions like a big white panel. It's just a little tiny peanut panel. It's kind of the industry phrase for it. So from that progression to these guys, one of the things to talk about quickly, these happen to be analog switches. But it's the same device, same looking device from the front as a digital switch. And that's on purpose too. Two button station, 2 wires in a common, 3 button station, 3 wires in a common, right? Works in conjunction with that because that guy does not support digital. When I step into a panel that I want to be digital, I just change the switch from an analog switch to a digital switch. And then rather than having 3 wires or 4 wires to the station, I have 2 wires to the station. And I'll bring up a Riker diagram that you guys can get the details. Actually will be helpful to you as you're designing because it actually has really panel schedules, et cetera, that you can fill out and show you how you logically start at the start and finish at the finish and design a low voltage control system. So the 2-wire data line is really important to us because every device hangs on the 2-wire data line. Okay? Whether it's a network node or a switch or an occupancy sensor if I'm going to tie the occupancy sensor in, or an exterior photo cell or a daylight sensor, everybody ties on the 2-wire data line, and it's a simple start. It's any configuration you want. It doesn't have to start here and end there. We can bring it to a junction box and start, we can do whatever we want to, whatever the field conditions are required. So we sit down with contractors at the start of each other to explain how that works to them, because it isn't like traditional line voltage wiring. I don't have to bring everything to a switch drop above the switch station and then bring my lock on and switch it on. I can run this any way I want to. It doesn't make any difference as long as I get those 2 wires into space and get to the switch, I can address it. When getting to digital, we get really, really cool. Now, so as this whole evolution is happening, the digital switches also field addressable at the switch, right? They all have an individual address. The system needs to see that address and know what it is. So we ship out 150 switches, and we don't tell the contractor. They don't have to go in S1, S2, S3, S150. The switch goes wherever it fits. Just open the box and put the dump in the wall. Whether it's 1, 2, 3 buttons, of course, makes a difference. You can't add or subtract buttons. But if it's a 4-button station, I don't care if it goes in this room or 3 rooms. It doesn't make any difference to us. When we commission it, we have a handheld device that goes up to the switch. We talk to the switch. The switch is, yeah, I'm here. We tell the switch where it lives, and now the switch is switching whatever we want it to. And I can program it to do whatever I want to. Huge advantage because if I'm, say I'm doing a school footprint and I've got this big, massive campus I'm working with, in the admin office, I want to have switches that do very specific things, right? Whether it's a panic switch because something's gone wrong, or it's after hours and I just want a central location to switch from, I can very simply address the switch, program it, tell it what I want it to control, right? You're going to control relays 1, 3, 5, 7, 9, 12, 14 in this panel, and these switches, or these relays in that panel, and these relays in that panel, and then that one button is going to turn all of those things on. Happens all the time. When you think about schools, especially like a rural school, rural combination schools where they're built up and they become everything, they're the community theater, right? All of the community basketball games get played there, from the little guys all the way. Everybody uses it, that promise something, right? You need to be able to address it, you need to be able to program it, and it needs to be relatively simple. And even if you're not going to reprogram it, I need to have access to someplace straightforward that I can turn things on and off without having to get back into a relay cache, right? The electrical rooms are locked after hours. So do I have to have a janitor or somebody there the whole time? No, not if I put switches in the right places, program them to do what they're going to do. And I can have a teacher, whoever's going to be there that night. All I need to know is that this switch turns that on, right? So that gives us all kinds of flexibility when we're dealing with end users. So we talked a little bit about strategy from a switching standpoint. Probably the single biggest trend in lighting control right now is, and it's not an artistic advantage, it just changes our business a little bit. Rooms like this do or don't have to be on tied back to my relay panel. It doesn't. I don't need to tie this room back to my relay panel. I can put a low voltage switch on the wall, tied to a power pack, and tie that power pack to an occupancy sensor. Take it completely off the bus. Doesn't need to be on my data line at all because I've got an occupancy sensor in the space. Right? When the occupancy sensor doesn't see occupancy, it shuts the lights off. Do I need a relay panel to do that? Probably not. In a building like this, 5 years ago we would have had relays assigned to all of these classrooms. Today we would say, no, don't put relays in all of those classrooms. They can be standalone locations, occupancy sensor, local switch. We'll talk about the local switch reason in a second. But I want the corridors and the common area spaces to be tied to the relay panel because I do want to be able to control those. Right? I want this off, and I don't ever want those corridor lights to be burning 24/7. I want to put a timer function in, and the way to do that is back to a relay panel. So when we started working with occupancy sensors, the industry as a whole, because if you guys get into this, you'll find that we tend to really over-design things. We said, if we've got an occupancy sensor in a space like this, and I cross the threshold, if the lights don't turn on, I've located the device improperly. If the lights aren't turning on when I'm more than 1.5 or less than 1.5 feet from the space, right? And this was our own self-imposed deal, right? So when I walked into the space, if I didn't trigger the lights at 1.5 feet, basically my first step in the room, we're supposed to turn the lights and turn, right? Awesome. Doesn't make any sense whatsoever. 1.5 feet or 3 feet really doesn't. Okay? It was a self-imposed piece of stupidness that we all tried to do. And the baseline, and the reason I say stupidness is, if this room had no windows, and I walked in, I know I have to turn the lights on. I know that. I'm a pretty smart guy, right? And I walked in and the room's really, really dark, I'm going to turn the lights on. If I walk into this, so in that condition, I would walk into the space and it automatically turn the lights on for me. Well, okay, thanks for pointing out, but you don't think I'm that smart. Because I would smart to turn my lights on. But we very seldom see rooms that don't have windows, right? Daylighting is a huge, huge piece of architecture today. We use it on purpose to fill the spaces with light, try to cut down on lighting load. We're going to switch that outside row. Here's the windows. We're going to switch the next. We might switch that off. We might switch this to 50%, right? Because I'm harvesting enough daylight coming through the windows. So in the old scenario, if I walked in and I was going to put something on Chad's desk, I would walk in the door, all lights would turn on. I'd drop something on Chad's desk and I'd be gone. And I would have been in the room for about 3 or 4 seconds, and the lights would stay up for 15 minutes. It's a previous student, right? It absolutely makes no sense whatsoever. That's what the industry did. We've always had the ability to not do that. We just didn't do that. Because typically we would tie that sensor and power pack to a line voltage switch on the wall. So that line voltage switch told us what was going on. The line voltage switch was closed. I walked in, the lights turned on. If it was open, it didn't turn on, and I had to turn the lights on anyway, right? New ASHRAE, California's code, Wisconsin's code, Minnesota's codes that required as well. That, what we used to call an occupancy sensor, is now really a vacancy sensor, right? So we'll go back to what I said. I'm smart enough to know if I need to turn the damn lights on. I mean, really? If I'm not, I probably don't belong here anyhow. So now that sensor, rather than turning the lights on, only keeps the lights on, right? Manual on, auto off is the control sequence, and the industry calls it a vacancy sensor. So I walk into the space, I look at something on Chad's desk, and this still happens, even in today's email age, right? It still happens all the time. Someone will come in, and they've got a memo that needs to get on everybody's desk, and you'll see this happen, and you'll see buildings that are wired with traditional aux sensors. And if you stood outside, you could watch the light turn on in this room, and turn on in that room, and turn on in that room, and 15 minutes later, these would turn on, those would turn on, and those would turn on. Unbelievable, right? About as silly as it gets, because I probably have enough light from the corridor to what I need to do. So now the control scenario is, I walk in the space and nothing happens. The aux sensor sees me, right? And we can put auxiliary contacts on the aux sensor so that if it sees me, there's a delay built into the VAV, right? So if I walk in the space, the occupancy sensor sees me. If I'm in the space for 15 seconds, the VAV picks up and says, gee, maybe somebody's really in the space, and we'll condition the space now, right? Or we'll change its conditioning, right? And if I want the lights on, I have to turn them on myself. Right? So we take that to a low voltage switch on the wall, tie that to a power pack on the ceiling. The power pack feeds the occupancy sensor. Makes a ton more sense. Right? From an energy control standpoint, it makes a ton of sense. We would build fluorescent valves, let's talk about those. Fluorescent valves were built as an instant start valves. That was how they were built for years and years and years. Because you turn them on and nobody ever shut them off because you had the wall exchange, right? So you walked into space, you turn the lights on, lights run all day, didn't make any difference. we introduced occupancy sensors, which were turning lights on and off all the time. And what we found was that with that instant start, we were hitting the cathode of the lamp so hard that lamps were failing at a ridiculous rate. They were failing in 25% of the rated life, lamps were burning out because we were striking it so hard. So to deal with the poor concept of turning the lights on automatically every time somebody walked into the space, we built a new balance called a program start balance, which soft starts the lamp, right? There's maybe a second and a half delay in which it preheats the cathode. Once the cathode is preheated, it strikes an arc and the lamp starts, right? And the phosphorus flow. Way different than the way the instant start worked. The instant start worked really if it needed 530 milliamps to hold the lamp, you would strike the lamp at about 1,000 milliamps or a full amp, right? And that's why you would blow lamps off because you would strike them all the time, right? The bathrooms, classrooms, places like that. If you look at lamp ratings are based on a 10-hour start. And what happened when we introduced occupancy sensors was they weren't running on a 10-hour start, they were running on an hour start, or 2-hour start, or 3-hour start. The green struck way more times than they needed to be. Whether the program start balance is the best balance, it truly is. It's the best balance for the lamp, it's the best balance for the lamp life and balance life. But we're no longer striking like that, and we will discontinue striking like that because now we've gone to a vacancy sensor scenario where we're going to occupancy. We're not turning the damn lamp on every time somebody walks in the space. So big changes in how that stuff is going on. And that'll be the basis of design as you guys are going forward. That just will be how things get done. So that low voltage switch is just an analog switch that I've tied to a power pack on the ceiling that does my switching faster.
It just came to my mind that we have a bathroom here at the rent level. It has an occupancy sensor with that applied at the bathroom, for example, and when you walk, right now you walk into the bathroom, the light goes on for 15 minutes, I believe. How would you apply this one in the bathroom? So you have to basically walk, when you walk to the bathroom, push the button.
And code's going to require it. There are some exceptions in the code, and I think that, and they allow restrooms, I think, to be non-convenient. You could tie that back to real time, just have a convoy business,
Yeah.
right? But they do allow bathrooms to be auto on because most bathrooms don't have windows, especially in commercial spaces, right? So there are exceptions in the code that you get around that. Yeah.
Well, I see the advantage of it in a room like this. So like you said, walking to grab something, there's no need for the light to come on for 15 minutes. And when you just walk in a minute, you got your business around.
Yeah, and it was always reliant, back in the bad old days, again, 18 months ago, it was reliant on the position of the line voltage switch on the wall. So if the switch on the wall was in its closed position, the lights would turn off and the occupancy sensor didn't sense you anymore. So if it didn't see anybody, 15 minutes later it would shut off. But the switch was closed. So the next time I walked in the room, the lights came on. Right? It just made no sense whatsoever. Or turning around the other way, I'm leaving the room and I know I'm going to turn the lights off, so I don't leave it to the aux sensor, I turn the lights off, I leave the room and I come back in the next morning and the lights don't turn on and I'm turning the switch on. I did that in my room, that's not what happened in that room. That room turned on because the switch was closed. All of it made no sense. It was just really helter-skelter. We would see this in clinics and hospitals where we would do a whole row of exam rooms, right? They're basically 10 by 10 cubes. With an occupancy sensor built in all of them. And one would turn on when you walk in, and the next one you have to turn the switch on. When you walk in, the next one would turn on automatically. Because there was no rhyme or reason to it. It was just the way that people were designing things. So that's all going to change. The vacancy sensor makes a lot more sense. It's a better value for everybody. It doesn't change cost or anything else. It's just functionality of the device. So from there, and this, and I don't know how deep you guys want to do it. I don't know how long more at the top.
The one for
on purpose? Oh, careful. We have to order lunch, Jerry. So, we also have components that fit in here that allow us to do load shedding, and this is called a demand flex ballast. That lets me basically use the power wire so I can switch the ballast in that fixture to a demand flex ballast and control it over its existing power wires, not pull additional wires to it. Right now, typically in a space like this, if I want to control it any other way than on-off, if I want to use daylight harvesting or something else, I have to be able to pull the two control wires. The purple and the gray wire have to come back, right? The 0 to 10 volt wires have to come back to a switch station. Some places it's not a big deal, in other places it's a huge deal. If this is a hardwood ceiling, if this is a gyp ceiling, that's a big issue. Even if it's not a gyp ceiling, even if it's an ACT ceiling like this, I still have to go in there and I have to tie all those fixtures together and bring that purple and black all the way back, or that purple and gray all the way back to whatever control station I'm going to use. From a labor standpoint, it's very expensive. We're not the only ones. There are other people coming out with power line carrier ballasts that let me talk to that ballast digitally over its power line. So, not pulling an additional wire to anything, I can just simply change the ballast and have it do different things. And now I can program to do whatever I want it to do. I can program daylight harvesting or inboard outboard switching, time delay. I can do all kinds of things with it just over the power line without pulling additional conductors. So, big advantage, and that's all stuff that's getting designed in on the front of the buildings now. You'll hear phrases like Dolly digital addressable lighting interface. Never really got adapted into the U.S. because it was fairly complicated. It brought the controls down to a really granular level. I mean, when I say granular, I mean on a per fixture basis, right? And all looks really good. I love to use the phrase look good in plan view, right? So in plan view, it looks really brilliant that I can tell that fixture can do something, then that fixture, and that fixture can do something, and that fixture. But the reality is it's never going to happen, right? And in this room, it's not going to happen. In a commercial space, I don't want it to happen, right? If I'm the manager at G Corporate, B Financial, right, and I've got this whole floor of queues, the last thing in the world I want is everybody at their desk turning the light above them up and down, right? It's distracting. It looks terrible when you walk into the floor. It looks like you got a whole bunch of burnt out stuff, right? Because that one's dim and that one's not. Individual conditions. Think tank groups will tell you that if you give individuals more control, their space will be more productive, and I'm not going to argue about that. That can be whatever you guys believe. But aesthetically, it looks terrible. It makes a lot more sense to control and keep that light at consistent level, right? If I'm targeting 40-foot candles, I want 40-foot candles throughout the space. And whether I'm getting it from daylight or electric light or a combination of the two, that's great. But I still want 40-foot candles. And I'm okay if that row is dimmer than this row, as long as it's the whole row, right? I don't want 3 up and 3 down and 2 off. Again, it looks like I'm not maintaining my building. Horrible impression on customers, especially if I'm publicly traded and I'm trying to impress people and sell more stock, right? I need to make sure my building looks like we actually know what we're up to. So, I'll switch over. We'll talk about this stuff in a bit. You guys are going to go into a design program where you're going to design a space and Chad's going to make incorporate low voltage control.
So there's a website that's very helpful for you. I will tell you that, oh, bounce me out. 2 years ago, a very enterprising young man in the class who was going to do his lighting control study called me, and he was a pretty clever fellow, but not that clever because I've been around a little bit. Really thought that I was going to help him do the lighting control design, and the answer is no, we're not here to do the lighting control design for you. That would be silly. That's what you're here to learn. But there are websites available, and I'll show you Douglas's site real quick. Oops. There we go. So in Douglas's site, there's products and contact, all this other neat stuff in there. Just going to talk about specs right now and kind of step you through how this designs out. So I want to pick up this one-line generator is going to generate a one-line for you in AutoCAD. Okay, that can be incorporated right into your AutoCAD drawings. We don't have this in Revit yet, but that's not that far away.
You can always import that forever.
Yes, you can. And we are creating BIM files for most of our devices, right? More for conflict resolution than anything else. But so I've got a one-line generator that will help you design something. So this just steps through. What am I going to do? So I was talking about the basic system. That's this guy here, right, with a time clock and a relay scanner, a network self-config, network web server, because that's really where things are going, and there really isn't a reason to use anything different, particularly if you're going to start messing around with this. So you can kind of step through this. So I've got a low-rise commercial. That's 3 floors. There's a single riser and a single panel. I got a total of 3 panels. This will be the exact same system that we used at the Twin Stadium. It's the exact same system. It's just in scale.
One riser means the 3-story and
One electrical riser, right? Not unusual to have if I've got a bigger commercial building that's only 3 stories. Maybe I've got 2 risers. I've got 2 electrical risers, right? So then I'm going to put a relay panel. The relay panel is going to go in the mechanical room right next to the lighting panel. It just always does. It's almost never that we don't put the 2 together, right? All right. Okay.
I think he's the most, they're the most secure probably. Like, it's the
All right. So I want to blow this guy up so you can see what we did.
the mod space, you can see that.
To who?
The mod space.
Okay, Chad's going to drive that side.
Okay, so you can go here. I don't know if that's what you want.
Yeah, I wanted to be able to blow
Yeah,
that.
I can zoom. See, there's
Yes.
a wheel here.
Oh, okay.
You
Perfect.
can zoom and drag it. So there's a sensitivity. Just zoom out with the wheel. And the wheel out, wheel.
Okay, so now I want to blow this side up.
Zoom in. And the other way. So, I got it. Just there you go.
Oh, I can't see. Oh, there you go.
And it's just a little bit sensitive.
Mm-hmm. So let's see.
If you click on the wheel itself, you can drag it around too.
Oh, okay. So this is going to give me a one line that shows me everything that's associated. Do you understand the purpose of the relay? Okay, the relay is a switch, right? It has the same functionality as that switch on the wall. Okay, what it does is let us break circuits down. So I have a single circuit coming that's going to feed 3 classrooms. Right? What the relay does is have me break that classroom down into different switch sections. So every time I want to switch, if I'm going to switch these 3 rows independently, that takes 3 relays. Single circuit, right? But it gives me control of the circuit itself, so I can break it down into more usable loads. So I'm going to guess this building is 277 volt for economy, right? But I don't want to switch the whole thing together, so then we have hot like switch drops, line voltage, that give me some functionality, but a lot more home runs, right? And a lot more circuit breakers. What it really does is let me take that same single circuit breaker and break that one breaker down into multiple loads. So if you think of the relay as just another switch, so I've got a switch that's back there, and then I'm just turning that switch on and off with a local switch. Okay, does that make sense? Yeah. So what we're showing you here, and that's I'm struggling, Chad.
Still.
Here, there you go. You drive and then
So which one do you want to focus
just
on?
over here real quick.
Right here?
Okay, so all we're showing you here is that we've got a class 1 line voltage section of the panel. That's where the relay or the transformer is going to fit. So I've got a transformer that has to live in there. It takes 120 or 277 volt feed to it, and that's what powers my panel. So there's my transformer on the
line voltage side. That feeds the DIN rail and feeds all the relays on the low voltage side. So I have to have that primary feed just to energize all the control electronics. And that has to happen in each and every panel. So then when we break that panel down into multiple relays here,
Go up a little bit.
there we go, yep. So now I've taken these 4 relays just as representative, and I've tied those directly to an output. That's in a very simple system. So I've tied those together in a simple output on a scanner, and now I can program those outputs to do whatever I want them to do. I can combine them. 1 and 2 can do the same thing. 1, 2, 3, 4 can do the same thing. 1 and 5 can do the same thing. It doesn't make any difference, right? That's all programmable from that point out. What I really need to do is land the circuit on the line voltage side of the relay. I need to land the proper circuit to it. So I can't program the hardwiring, right? Once it's in, I can program it, but I have to know what circuit's being tied where. So when we'll look at the panel schedule, we'll show you why that's so important to us. So we break that down. This number is going to tell you the number of conductors. There is a key down in the lower right. I think that's it. Nope, right in here. There we go. So this key is going to tell you what that wire is, whether it's a Belden cable, an Ethernet cable, a crossover cable, or just a simple 18-2. So it breaks that all down for you and tells you how things hang. So these guys blow up, and now I've got a button station that I need. You're doing that on purpose?
No.
No. That tells me that I need to have 2 conductors to that single button station, right? So it's a really simple riser. A lot of folks are using this, a lot of design firms are using this because it gets their point across very straightforward. Whether you're using all those devices, whether you're tying the occupancy sensor to the system or you're not tying it to the system, and that's all editable, of course, because it's just an AutoCAD. It's your drawing once you download it, right? If you can scroll over to the far right, here we go, over here into the schedules. Okay, so one thing that a lot of firms are struggling with, and I mean a lot of firms, so my job inside of our company is to call on some of the larger electrical specifiers in town. So Hallberg Engineering, you guys know the guys from Hallberg, right? Joe and his crew, they've been in here several times, I'm sure by now, right? Whether it's them or Dunham or Machad or HGA, all of those firms are people that I do business with. And they all struggle a little bit with lighting control, especially to the extent that they're using it now versus what they used to use it for. So we developed this schedule, and people are using it and now they need to find a Revit version of it because they want to populate everything automatically. But it doesn't make any difference. But what we're trying to get across is the more descriptive their schedule is, and the more columns they have in their schedule, the more clear it is to everybody as to how things are being controlled. So if you can zoom that down just a smidge less, a little bit smaller. There we go. So this is our schedule, and the left side mimics the right side. Okay. So this is the same as that. What we're asking for is some simple information, because after you've drawn it all, you're going to send it off to electrical contractors. You're going to send a copy to us. We'll send it off to our manufacturer because they're going to do a full takeoff. We need to know what you're doing, how you're intending to control each of the spaces that are running through this. And there will be circuits that aren't controlled by this, and that's perfectly fine. So we ask for simple things, a room number, maybe a description, because the room number that shows up on the plans that you guys are working on are not the room numbers that are going to be associated, right? In this building, if this is 101 on design plan, this room is going to be room 312 to the school, right? So we want you to tell us what room it is, and a lot of times architects, when they're building their background, they're telling you what the room is. It's the cafetorium, it's the electrical room 1, electrical room 2. So if you give us those descriptions, we can find out what it is you're talking about. We ask for the circuit that you're feeding from, right? Or the circuit that it's coming from. And we'll back up a little bit. When dealing with low voltage control, anytime I feed from a second panel, I have to bury it. I can't bring a feed from 2 different panels into a low voltage panel and not have a physical metal barrier in between. It has to be. And if I'm going to bring life safety in from a life safety panel, I have to barrier that as well. So every time I feed from a different panel, I have to put a physical break in the pin. It takes up about 2 relay spaces to do that, and it's something that we plan through.
So you could actually expand the circuit. It isn't unusual to do that at all. Actually, it happens quite often. So maybe I'm going to say that this is what we call it a circuit here, but maybe I want to call it LP1 circuit 1, and I'm going to call relay 5 HP1 circuit 1, right? That tells me that there's two different panels feeding this thing and that I have to physically build that breaker. Okay? And by code that has to happen, and that one the inspector does find every single time. You can't come in from the second panel and not have that barrier built in. So we know what the room was, we've given it a description, we talked about which circuit it is. Now LP1 could be LP11, 1, 1, 1, 1, because what I'm doing is breaking down that single circuit into switch loads, right? And I'm doing it at the relay level, not at the classroom level. So now I've taken circuit 1 and I've broken it down into 5 or 6 or whatever number of switched legs that I want to have, because I'm going to do different things with it, right? So again, I've got these 3 classrooms all on that same circuit. So the room number is, room 101, 102, 103, 104, but it's the same circuit, but obviously it's different relays. Does that kind of make sense to everybody? What we're trying to do on a really granularize this?
And we're Keith, just to interrupt here a little bit. We're doing it right now, guys. When you circuit, you can circuit multiple rooms on one circuit, but when you switch them, you switch them in different switches. So that's what Keith is saying is. So multiple, you have 3-4 rooms like in the office, when you were circuiting in one circuit, but you switch them from different occupancy sensors and different switches and what's not. Every time you switch, you need a relay on an occupancy sensor or on a low voltage switch, for the most part.
Good point. And I keep talking about the relay, talking about it being, that molded case device. If it's an occupancy sensor, that we call it a power pack, right? There's this little 2x3 device with a nipple on it that can hang right on the electrical box. That's a relay. It's exactly the same functionality as that molded case relay, right? It does exactly the same thing. It is just a relay. But we're talking about stuff that ties back. So then when we expand this out, we want to know whether or not it's a local switch, or whether or not it's a master switch. And again, that master switch, when we deal with master switch stations, typically it's in an admin office, head custodian's office, something like that, where I want to have a master switch station that can do multiple things. I want to be able to control big chunks of the building that I can't see, right? So in the admin building in an office or in a large library, don't have switches out in space. I do have switches out in space, but I've got an override of the master station that I can shut things down. So that's all we're talking about is whether we're doing a local switch, whether it's just a local switch. It could be a local switch, and then we could have a master switch tied to that same circuit, right? So that could be a local switch number 1, master switch number 1. Timer functionality or other functionality. Timer functionality tells me whether or not we're going to tie it back to a time clock and then use Astral or all of those other things that we can use to trip it, whether we're doing a time control with daylight sensing or what have you, or occupancy sensing. So we give this to the engineers as a template, just as something that they can expand. They can expand these and make as many columns as they want, because again, the control is going to get more and more and more granular as time goes on. So it's a good place to start. It helps you logically break things down. And a lot of guys, when they're building this schedule, they're building this as they're building their lighting panel schedule, right? So they've got LP1 here, and they're controlling it, and they know that LP1 circuit 1 is going to feed these 4 rooms. They go right to the relay panel schedule and say, since I'm on circuit 1, how am I going to break circuit 1 down? I'm going to take that to the relay panel and break it down right now while I'm doing it. Right?
And you guys will be doing that. For the project that we did, there's a schedule we already got from you a long time ago. Slightly different, similar, but different. You will be assigning a circuit to a location, to a relay, to a switch. Exactly the same thing. It's coming in 2 weeks. So.
Oh, my time is perfect then.
Yeah, it's so you.
Good. And again, this is all around AutoCAD, so you guys have access to this. You just go through the tutorial or through the Douglas website like we showed you, and step right to it, and you can import this stuff right into your drawings. It's very cool. It's a really helpful device. And like I said, a lot of guys are just taking this. After they fill it out, they just incorporate it into their plan sheets or make it a plan sheet depending on how complicated the riser is, right? And we've told it how many panels there are, so they'll give you that many panel schedules, right? If we told this that, if we said this was a 50, right, we said this was.
So these are based on relay schedule for the 3 panels.
Yep.
And with that one, there's 4 of them.
You would confuse it?
24, 24.
Oh, and a 36. Okay. Depending on your capacity. Oh, and actually that's a 72. Okay, they've changed that a little bit too. So 24, 36, 48, and 72 size tubs. We can build tubs from all the way up to 72 relays per tub, right? Which is pretty unusual these days, because you just don't see that much being done on the relay level, right? Because we're using more local occupancy sensors, right? 5 years ago, we had a lot more relays and way fewer rock sensors, and now that thing is turned over.
So that Keith, then they can choose based on the design here, which one of these they can use. So they're all the same, basically. You could have
Yep.
everything in this one.
Yep, this just shows you 72 relays versus 24 relays. That's all.
And 36 and 48.
Yep.
Okay. And then
So-
you pick whichever schedule you want.
As granular as you're going to make this thing.
Yeah.
From a solution. Okay. Not just us, but several others, and actually, if we can jump in and close this now, there's another. Yeah,
We can do it.
we can back right out of that now. Oh, actually, here we go. This is a fun function. Fun because this is what I do for a living. I know you guys don't find this as fun as I do, but we'll call it fun anyhow. Simple programming, how to program the Astro controller. Where'd you go?
You hover over the lower left corner. See what's yeah, that. Is it loading?
Mhm.
It's my laptop not doing it.
Oh, I think it's thinking.
Something like that.
You got too much stuff on your laptop. Okay, well, let's see if that loads or not. What that tutorial does is step you through whether you're programming a device like this, or you're programming a time clock, or you're programming a scanner. It lets you go in and take you through the logical steps of programming, right? And you can do it. You can't do it live from here, right? Because you're not dialed into that URL address, but it does let you come in. So you're an electrician, or you're a
Which one? I'm sorry, which one did you click on? That one?
go to this one.
That one?
Yeah.
It's spinning, it's spinning.
Yeah, for a second.
Yeah.
If say you're a project manager for a contractor and you're going to go out, you've got a system in, you installed it 2 years ago, it's a really, really good customer, and they call and they want to make changes, and nobody ever remembers how to change it because they haven't done a darn thing with it since you installed it, right? You can call me and beg me and plead and promise me more business and see if I'll come out and help you, which we almost always do. Or you can just jump on the web and open up how to program this and take a quick look at it. When you look at the devices, all the programming instructions are built right in it. They're right on the face, right? These are the steps that you go through. This just lets you go ahead and open that up and at your desk say, oh, okay, this is how I set the time. This is how I change groups. This is how I change time of day function or astral function or whatever. Lets you step through the whole thing online before you go out there and stand in front of your customer and say, I don't know how this thing works. Right? It just intended as a simple tool. So right there, start programming, and then it just, and so as you step through it, if you just pick on the start programming, you follow the red bouncy arrow, and it lets you step through all of those different functionalities. So if you pick on the first one,
Oh, that one?
Yep.
I just, yeah.
so pick on this guy. Yep. I want to adjust date and time. Okay, that's deep. And I can go through and adjust date and time. And it just, so this tutorial is just intended to give the guys out in the world a chance to do this without having to, because realistically, if that job's in Minneapolis, I'm probably going to come over and help somebody out. Maybe not on their schedule, but on mine, maybe sometime in the next week or so. But imagine that job is in Fergus Falls. Yeah, no, I'm not driving up. I mean, I'm not. We did our part. We fulfilled our obligation. I can't afford to drive up there changing all the programming all the time. So we wanted the programming to be as functional as possible, so that either they can do it or they can call an electrician to come out and do it. And if it's a good enough customer, they won't charge them for it. Right?
That's interesting. So you can do all the programming, get trained on it before you even.
Do all your training before you head out there. And we do this training with the owner. We have, and actually it's becoming a much bigger cottage industry, if you will. Douglas doesn't use third-party commissioning agents. All of Douglas's commissioning agents work for Douglas. Other companies have commissioning agents that travel around, right? And maybe they have a 3 or 4 or 5 state area, and they'll be certified to program Hubble Building Automation and Leviton and this guy. And these firms will go out and they'll have 5 or 6 guys inside their company. And they'll be certified commissioning agents for multiple manufacturers. So when a building gets commissioned, we fly a guy in from Douglas because that's how we do our business. Other companies have gone to this regional model, and you might be certified for 3 or 4 manufacturers. So if Leviton's got a startup in Fergus Falls, you're going to get that call, and you get to go to Fergus Falls, and that's part of your job, right? That's you. Someone paid $2,000 to have you come up there, make sure the whole system works, make sure you've done all the adjustments and programming and timing changes and all of those things, and then after you're done with all that, then you get to train the owner as to how this whole thing works, right? That's what that commissioning agent does, and that, like I said, that's becoming a very big chunk of the business right now, because there's so much that's going in and so much more that's going to be going in. This is going to be on every single project you guys touch. There's no question about it. So being able to program those is crucial, and relying on a third-party source like myself to come out and do it it's not the best way for a contractor to handle it. And we actually do some training in our office. We'll bring, if there's a contractor we're doing a lot of business with, using Douglas, say, we'll bring in, maybe they have 2 or 3 guys that focus on that side of the business. We'll bring them in and spend a day in our office going through this, doing demos for them, showing them how the programming works, so that they're ready to go out in the field and handle it themselves. And that's very important, because that's a profit center for the contractor, right? They're no longer paying me $2,000 to come out and do it. They're handling that themselves, and the contractor's not pocketing that $2,000. So the guys that are really in tune to this are using that as a profit center, and it is a good profit center, and it also reinforces their position with their customer, kind of locks that customer down even tighter, right? Not only did you spin all the wire nuts, but now you know how to program their system, and that becomes a very important thing to them. So.
A lot of lines are like recommend more for some contractors with
Yeah, no, I have to stay away from that entirely. That's a very dangerous line for us to cross. But for a contractor to use it in their marketing makes perfectly good sense, right? So I can't go to an owner and say XYZ Electric is a certified Douglas guy, right? But they can certainly market to their customers that they are that they have on staff authorized service technicians.
Can you download after you program everything else, can you download it into the machine?
No, not yet. Not yet. That functionality
This
is
just
not
strictly training.
This is strictly training. That functionality is not that far away, and what's going to happen is you're going to be able to, whether you do it here, you could do that here, and there'll be a SIM card slot, and after your programming is in, you can slide a SIM card in, download it to the SIM card, take the SIM card to the site, and plug it in.
But you
That's-
guys can do it electronically, right? You can do the programming in your laptop, download it into the panel.
Not with this system. Okay, so in the next system up, so we've gone from this system, when we go to this system, which is web-based,
Nice.
if I get IP address, if I get access to their IP, then, and typically, and it happens all the time, right? A school will want us to do something, or prior to doing the startup, actually going out and training the owner, they'll grant us access for 24 hours. We'll have a tech jump on. He can ring the whole system out, make sure that everything works like it's supposed to work. He's working real time, so he sees what every relay is doing and not doing, right? So he knows that all the functionality works, and then he can work real time and not switch the relay off. Okay, So he can know that that relay is functioning and that the switches are functioning and still not do anything in the room. So the classroom is operating as a classroom, but we're not switching lights on and off in the middle of the day, causing confusion and all the rest of the things. So when they give us that access, yeah, we do that remotely. And then it's because the important thing is for us to get out there. We don't want to spend that text day or 2 days or whatever we've allotted for it, wringing all this stuff out, right? We want them to spend the time training the owners to how this thing works, right? And again, those schools are getting way more sophisticated than they were a few years ago, and they have people on staff that are very tuned in. So if you can get 4 hours with their guy, you can show them exactly how it works, and then they don't have to come back to us and ask us for help.
So, are you guys getting to the point where you can do like set up something on a SCADA for like larger buildings where they can monitor efficiency for lighting, everything in there, so that they can know like if there's like a certain equipment that's not operating at their efficiency. Like at Target Field, like if it's a LEED certified place, you know, if they want to monitor that sort of thing, a large building, you guys get sort of that, like a SCADA system.
Yeah, there's a bunch of different ways to do that. Probably the most common is not through us, because we're really a switching system, right? So a lot of times we'll incorporate a node to talk to their building automation system, because that's where your work's going to come from, right? So they're in a building management system. We use the phrases interchangeably, BMS or BAS, right? So whether they're talking BACnet or LAN, or it's a Johnson Controls system, right? We have a series of gateways that we get. We have a gateway that lets us talk to anybody's building management system. We just have to know whose it is, right? So we convert Johnson Controls Metasys building management system. We put a gateway between it and this that lets them see us downstream, right? Lets them do programming, which we really, really don't like, because quite honestly, they do mess up the lighting. When I have to go back to a building because the lighting control system is messed up, 99.9% of the time it's because the building management guy then started trying to change lighting functionality. It's not the same thing. But then they can monitor downstream, and they'll know exactly where they're at. So hours of burn, and they can go very granular. They can know hours of burn. If they're keeping things up to date, they'll know when they change the lamp lights. But that happens on the building management side, not on the lighting control side.
Okay, so they were installing some systems, stuff like that, make sure it's all functional from that side.
Yep.
Okay.
And so that little card back there. That little card happens to be lawnmower space, right? So any lawn manufacturer can tie into the data line at that port, and if they're a lawn certified manufacturer, they can tie onto that, and they instantly know everything that's going on downstream. If they're not lawn and they're BACnet, there's a different device that we use, and if they're not lawn or BACnet, then we have gateways to deal with it. So it could have been a Honeywell system or a Johnson Controls system or whoever. If they're not using an open protocol like BACnet or LAN, and they have a proprietary software, which like Johnson Controls does, right? So their Metasys system is proprietary. They want to know what we're doing, but they don't want us to know what they're doing, right? So all this black magic behind the curtain stuff, that's fine. We just build a gateway, which is really simply a hard drive that converts languages. Right? It converts their language to our language. Actually, it goes the other way. It converts our language, our LAN language, to their Metasys language. And so they plug in on one side, we plug in on the other side, and now we've got a translate.
So you guys trying to stay more open then versus like kind of focusing more on one like proprietary system that might work a little bit more integrate a little bit easier with you guys?
You have to be, at one time, this will take it back a long ways. There were, prior to DVDs, there were two tape systems, right? Betamax, right? VHS and Betamax, and it was the big war, which was the smartest system. And everybody was, not everybody, a lot of people were really confident that Betamax was exactly the right system to go. And probably 30% of the population bought Betamax players. And then Betamax failed miserably, and all of that hardware that you bought was complete garbage because it wasn't supported by anybody. You couldn't even buy a tape. You couldn't rent a tape. It was trash, right? The 3 Disney tapes that you bought because they were like $28 a piece, that's all you got, and you can't find anything else for. Controls kind of went the same way. There were two protocols being used, BACnet and LANWorks, and they were kind of doing the Betamax VHS thing, and those are independent groups, right? You authorize through law, or you're authorized through BACnet, and you build your devices to go that route. But they wised up before they got to the whole Betamax VHS crunch, and they said, let's stop doing this. Someone's gonna lose, and none of us should lose, because we're wasting time. So now you have gateways they can choose back and forth between. So yeah, I don't ever want to be, I can't log into lawn only, and I can't log into Metasys only. There's too many building management systems out there for me to be exclusive. Right? It would limit my potential.
Yeah, I just wasn't sure if there was one that like just ended up like inadvertently being a little bit more cohesive with your guys' system as far as will not work better.
No, it really doesn't matter. It really doesn't matter at all. Because our system is completely self-sustaining by itself, independent of theirs, whether they've time on our data line or not, we're completely self-sustaining, self-supporting. All of our timer functions, everything else lives right inside of our system. So it doesn't matter and really what we know is all they really want to do is monitor. They don't really want to come into the building management system and make changes, because we make all those changes on our side. They just want to log into it after the changes have been made and the building is set up, and be able to monitor what's going on.
You just want to make sure that your data transits back to the system.
And then what they do with it and how they lift it and drop it upstream is, yeah, they can geek out. They can do all things that they want to do. Like I said, we really prefer that we stay standalone. I don't even want to tie into my system, because more often than not, when we have a problem, it's because the building management system guy has decided to go in and start making wholesale changes in lighting control. And it's not the same functionality, it's not the same language you're going through the translator, and they will do all kinds of crazy stuff. They work off of a 24-hour clock, right, 1 through 24, rather than us working off of a 1 through 12, 1 through 12. We use AM and PM, military time, right? And I'm going to tell you, the number of times that I get a call saying, all our lights turn off at 8 o'clock. AM or PM? AM. Good. Your building management guy is using his 24-hour clock, and he's using 8 o'clock as his off switch, but he read him at 8 p.m. Right? So he's forced an off switch into my system, and I didn't need in the first place, because I've already got it built in. Right? He ran it through his building management system, so he's forcing off switches on more relays that don't belong there. He's sweeping off all the lights in the classroom at 8 o'clock in the morning, and it would freeze up. Then we all go out there and have a big meeting and have an argument about it, and we find out that it all came from the building management guy, just didn't understand what he was doing. So we prefer to be standalone at all times. I don't mind if they log in. I mean, really, it's not like this. I can't tell them what to do. But if they want to log in and take a look at it, that's awesome. If they want to log in and start making changes, it almost always leads to it. So, real quick, I just want to step into, so that's really where the world is today. This is another company that we represent called Building Automation. You guys have all seen things that look a lot like that, right? Wireless routers for your house, your office. This is a wireless router for lighting. So, same concept. I brought the internet in. I brought power in this device, right? It sits in somebody's office, someplace near their computer or whatever. I just have the circuit with a dial like this. So I've got 120/277, please. I've got a purple and red here as well in case I'm doing any data control. And I've got some output ports. I put this guy up in space. This guy gets talked to by this guy. Right? So now I'm doing all that functionality that we were talking about, the true wire data line that I'm stringing along, and I'm putting switches and everything together. Now I put this guy out in space, and I've taken all that wiring analysis. Huge advantage for retrofitting existing construction. When you look at building codes, anybody here from Bloomington? Me? Okay, so you know, City of Bloomington has one of the strictest energy codes, lighting codes in the state. And Bloomington tells you that if you're going to upgrade the wall pack on the outside of your building on a commercial project, you've got to upgrade everything. You've got to do a full wall. Right? So, and if you're going to do the new launch, you got to bring it up to today's code. And as soon as we enforce ASHRAE, now it's not just new code, but new ASHRAE compliance as well. So when I sit in the parking lot, now I have to be able to switch that lighting from 100% to 50%, maintain uniformity. Well, just completely almost, right? I'm going to try to pull additional conductors out to the lighting fixtures in order to make that work. So what this guy lets me do is address any of those fixtures. So I've got a guy like that. I've got a guy like this we call it a butter stick, and that's the nastiest looking piece of butter you're ever going to get. Butter stick lives in the fixture. So I've got an antenna on this. I've got an antenna on this. This runs at like 900 gigabytes or whatever it runs at. It's a military encryption that they switch every microsecond. It's a very secure system. I don't know who's going to hack into my lighting system. Maybe at the Twin City they would, but I don't think at the corner lot in Bloomington anybody's going to hack in. But this lets me put this device in, whether it's that light fixture or say I've got a pole mounted light with a photocell on it. I can take the photocell out, put this photocell in. It's got the same unit configuration as the photocell on the top. Now without adding control wires, I put this in the photocell of the fixture that's sitting on the parking lot. I can talk to this photocell from the router and tell it what it's supposed to do and when it's supposed to do it. And now I have complete wireless control of all this fixtures. I didn't pull additional conductors out because I'm not going to be able to put additional conductors out. I'm telling you, as galvanized as that pipe is, if it's been in the ground for 20 years, it's got all kinds of things to be said. Try to stuff a fish tape through there and grab wire and pull that wire back out to the pole. Good luck. It is a monumental task at least. So now we get the capability of doing that stuff remotely, wirelessly. We do a lot of this in large manufacturing facilities. So I can go as granular, and keep using the word granular, I can go as granular as I want. I can put one of these in each and every fixture on the entire project. If I want to talk to each and every fixture, I can do that. If I want to talk to groups of fixtures, I can put this in. And I can tie, these ports are to tie in occupancy sensors, right? So each of these ports let me tie in an occupancy sensor or a local switch. I don't need occupancy sensors or local switches. I can program this from this, right? So now I can do huge bays in an industrial facility and do all the programming through it. So if I want to incorporate daylight sensing, I can put a sensor at that window, read foot candle levels, and then switch whatever I want to, right? Without having to go all the way down to putting a device per fixture. So it gives us huge amounts of flexibility inside of these plants. This is a combination. Both have their pluses and minuses, right? The minus of a system like this happened down at Minneapolis Convention Center, and it wasn't ours, and I thank God it wasn't ours because it's not something you want to be involved with. They went to a wireless system in one of the large pods, right, one of the convention halls. They went to a wireless system in there, and the system worked wonderfully out of the box. They brought it in, they hooked it up, everything worked like it was supposed to do. They had their first convention, 8,000 people came through the door. 8,000 people walked in the door with a smartphone, and we're all on that same Wi-Fi, and that Wi-Fi network said, what the hell is that? And it shut down, and they couldn't reconfigure it until they had everybody out of the space. Yeah. And they couldn't get it out. I'm not talking in the same depth with too much stuff on that Wi-Fi network, and it just completely shut down this part of the system. So you imagine those shows are expensive. We pay about $2,000 per day per 10 by 10 booth. Right? So if the fixture that's on my booth is off, and I spent $2,000, and the fixture of my competitors that's standing over there is on, I'm a seriously unhappy guy. Right? I spent $2,000 on the booth. I've got 4 people there. I've flown people in. I've shipped stuff in. I'm probably $5,000 into the day, and I've got no light. He's got all kinds of light. Doesn't work well for them in the convention center. I recognize that the very first time they fired it up. They had to disable the entire system actually and go back to a standard, more robust relay system that can't be penetrated by a wireless network.
Wired one.
A wired system. Yeah. So I'm a big fan of the wired system. I think this absolutely has its place in the world. It's relatively new. We did a car lot up in Bemidji using this system. Incorporated it with occupancy sensors outdoors. The purpose was twofold. They had some issues with vandalism. So they wanted a controllable system. They wanted to be able to turn the lights on and off. They went to an LED system. So what we did was we lit their lot as we would typically light it to about 50-foot candles. That's their show level, right? That's their foot candle level that GM or Toyota or whoever's going to mandate it. That's about the level that they want to see on the front line. So we lit it to 50-foot candles until 10 o'clock at night. Yeah, at 10 o'clock we switched it in half, 25-foot candles, cut their power. So we went from 465 watts to 200 watts, and then at 10 o'clock we cut it to 100 watts per pole. Right? Huge, huge energy savings for these guys without turning the lot off. Then we incorporated occupancy sensors in the lot as well because they had vandalism issues. So when somebody walks into the lot and the occupancy sensor sees them, all the lights come on, and the passing squad car knows there's somebody there because the lights don't turn on by themselves. Right? And we've incorporated that technology in city parks. We're working on some stuff for the Capitol complex over in St. Paul. Same thing, they have tons and tons of walkways, they're going to LED lighting on it already, right? We know we can functionally switch the LED up and down, it doesn't mind, it actually lights, it doesn't bother for a minute to switch it up and down. So at 10 o'clock on the St. Paul campus, they're going to switch all of their walkway lighting to 20% or 50% or whatever level they pick, right? When the lights come up, there's somebody there. So campus security knows that there's somebody there. If it's just me and I'm just walking to my car, great, because it sees me and I've got a nice fully lighted path to my car and it switches down. The campus security knows that I'm there, right? If I'm the bad guy and I'm trying to run away from them, as I'm running away, the lights are turned on as I'm coming, right? It becomes very straightforward. So there's all kinds of cool things that can be done, and those are really great applications for wireless, right? Because I'm not going to be able to get wires out to each and every one of those poles as I'm going through.
So the signal strength and that's pretty strong, but like you said, is it make it much more security issue for them if people are able to get onto the Wi-Fi from that phone or use it as a broadcast?
No, they won't, because of, and I'll leave you these books. And it talks about the bandwidth that they're broadcasting, and it's 900 something. They're using a military encryption code that literally changes every microsecond, right? So the ability to hack into this is virtually impossible. And even if they did, all they would get was this. It's not, we're not tied to anything else on the campus. All they would get into is the lighting control schedules. You know, I don't know what advantage that.
Like you said, like Minneapolis conventions, I don't know anything theirs, so theirs is a little bit more, I don't know, like a more budget version of it. So they, when they set theirs up, it wasn't exactly something where people couldn't piggyback onto.
Because that lived on a Wi-Fi system, you have 10,000 phones all looking for Wi-Fi, right, on that same Wi-Fi network.
Yeah.
That's what crashed the system. Too many people trying to access it. Too much noise on the line on the Wi-Fi line.
Interference.
Interference.
Interference. Not hacking, interference.
Yeah, no, that's fine.
Yeah, exactly right. Not hacking, not interference,
Yeah.
not hacking. So, but it's very, very cool. It's an interesting way to get around some of these problems. And again, this stuff is just going to continue to grow and grow and grow. The Douglas catalogs change all the time. We no longer, whether it's this or lighting, we don't update engineers' catalogs. The catalog library that you have there. 5 years ago, every engineering firm in town had a wall probably as long as the inside wall of your classroom, but it was floor to ceiling with lighting catalogs, and we all did, and we changed all our books and we put the, it's all trash, right? Nobody does that anymore. It's ridiculous. Because number one, I can't keep it up to date. I don't know where all those books are. And any information that I've published, if I printed this, what's its value? In 6 months, very little. In 18 months, none. Right? Too many changes. Things are happening way too fast. To have this be your reliable source. Back before we were making changes like this, the life of this catalogs was probably 5 years. Now the life of this catalogs is probably 18 months. It's not good for paper and print. Right? Stuff happens too fast. And nobody wants to go to it anyway. Right? Like I said, I've done this for a long time. The designers that are coming up now, they're not going to go and try to search out a catalog. Right? They're going to go on Google and find what they need. They would mine it down. You can see how granular you can get, right? Just by going down on a website, you can find all the way through it, find exactly what you need to have, and never get up and go search out an old catalog sitting on a shelf. Right? Doesn't make any sense. So.
Only the dinosaurs like Chad would like to highlight and bookmark and.
I still do, and it isn't like I mean, there's a reason that we print these because sometimes it's just a help, and it's
nice to highlight and
nice
write
to
a few
highlight. A
things.
lot of guys will take these books and go sit down with an outliner as they're talking about design. Because if you understand your outliner, you know how much or little he knows about what it is he's trying to do, right? And so if you went in and you brought all your plans in and you laid all that in front of him on the table and he's looking at it, I have no idea what you're just gonna completely lose him. So if you're not gonna, if you don't have at that level that you can talk to, that can really talk technical with you, then these books are a great help because it pictorially says this is exactly what, see, this is what your room looks like and this is how this looks, right? It's a very dumbed down version, but it's really helpful for those types of applications or those types of units. So
That's awesome.
that's lighting control.
Yeah.
I'm very impressed. Like I said, it's going at a million miles an hour right now. What we're doing today is going to be all different than what we're doing in 2 years. Most things are going to be backwards compatible. This device has already changed. This is the device that's hanging at the Twin Stadium. We replaced this with another generation already. Right? That generation is actually really, really cool because now on that device, I've got a push button that lets me ring out the entire, that 2-wire data line we're talking about, lets me ring out the whole 2-wire data line. I can press a button on this device before I go through and try to commission anything. The tech walks in, he pushes the button on the device, and it rings out the whole data line.
So you were saying before, like a lot of the other, like Suzuki's like a Cat 5, they've got a lot of connections for theirs, or like a lot of connection points. Do you see a cost savings versus your way of doing it? Even though the 2-wire is probably, is the 2-wire more expensive than the Cat 5 wire itself, but there's just more impact.
The 2 wires an 18-tooth thermostat, probably the cheapest wire available, right? So it's far cheaper than a Cat 5 or a Cat 5e. It's 2 terminations, and the termination can be, if you look at the back of the switches, do I have them? It's a screw load, right? I don't need a Cat 5 jack. I don't need a stay-on connector. I don't need anything. I wrap it around the terminal like a wireless switch and tighten it down. So I don't have any of that other hardware. I'm not trying to line 5 or 7 or 9 wires into a specific place on the back of that Cat 5 jack and make sure that everything fits, right? That's where most of the software comes from. For us, it's a question of polarity at that point, right? So I walk in, so our tech walks in, he presses the button, it brings up the whole data line, doesn't see any shorts in the data line, there's no misconnections in place, nothing's been crossed. Awesome, he knows at that point that he can do all this programming from there and never have to go device to device to device, right? Until he gets to that point of programming. So now he knows the whole system works, so he can go in and he can tell each relay what it's supposed to do. Then he goes out and identifies each switch, tells each switch what it's supposed to do, and the whole system works very clean. Right? So this device is probably 4 years old. It has been replaced already about 12 months ago with the newest greatest upgrade. That's how fast it's up. Very cool, very dynamic stuff. So you guys are all on the design side, right? Anybody working for a contractor already? Oh, okay. Okay. So I work with a lot of your folks there, Lisa, and the lighting group is where I spend most of my time. Anybody else looking to get into business?
I just do that. Doing small sample now.
Yeah. For a while.
Yeah, for a while. Just tell schools.
Sure. A lot of stuff going on. The industry standpoint, we're seeing positive impact, economic impact across the market, across all of us. My trade area is 3.5 states, so I have half of Wisconsin, all of Minnesota, and all of North Dakota. And for the first time in 8 years, I can say that we're seeing true positive impact, economic impact. Not just federally or state-funded projects, but we're seeing private money invested for the first time in a long, long time. We're seeing electrical firms, Machad's and Dunn's and people like that are busier now than they have been. They actually have backlog. None of them talk about backlog. 6 months ago, they wouldn't even use the word backlog because it was like the jinx, right? You didn't say, yeah, I think I got some backlog. You just never said it. They're starting to set an NLC backlog. There's real projects, private funding projects, which change how our business goes. So, guys, honestly, I think for the first time in a long time, we're coming into the business at a time when it's kind of accelerated. We're ramping up, and I don't see the slowdown happening that we had all been afraid of before. So good luck. I hope it all works out for you. So, and remember, we're not here to design your whole project first and do your own homework.
Actually, I have one more question too. You said there's a huge amount of interrupt on the switches for the lights. Do you think they're trying is it worth it trying to capture some of that interrupt and it's just trying to spit slowly across? or you guys just use kind of like a, like shunt it, put it back around or anything, or what?
You shut it and get rid of it. No, you really can't use it. It's maybe a cycle. Well, and actually, that's a whole other topic, right? What comes from the lighting side comes from the driver's side. So in an LED system, depending on whose driver you're using, that driver you could see 1.5 cycles of really high inrush. A really poor driver, you could see 10, 12 cycles, right? At which point you're going to trip a breaker because the inrush is probably double the operating current,
Yeah.
right? So if you design a circuit to 12 amps, so you've got a lighting load that you design at 12 amps, now you can go to 16, nobody goes to 16, right? Most firms are pretty conservative. So they designed it to 12. It's a full LED load on that circuit with a 12 amp operator, right? Because that's the information that's easy to find, right? You know, the lighting cuts and the light fixtures, and they'll tell you what its input loss are, what its input draw is. You have to mine a little deeper depending on who you're doing business with, and the manufacturers. So good manufacturers will tell you what their inrush is, right? Bad manufacturers won't. And there's a lot of bad manufacturers. They won't tell you that their inrush. So good manufacturer, maybe he's got 1.5 cycles of times 2, which isn't going to hurt you, right? Bad manufacturer might have 10 or 12 cycles of times 2. So now I've got an inrush. So instead of operating at 12 amps, right? And with a 1.5 cycle or 1 cycle inrush of 24, which everything will handle. The relay will handle it, the breaker will handle it. That's not a problem. But if I've got 10 or 12 cycles at 24, I'm going to trip something, right? I'm going to trip a circuit breaker because I'm running at 24 amps on a circuit breaker rated for 20.
Yeah. So I mean, does that mean you guys are staying away from like doing a really good job trying to stay away from that, just in case like, you know, it's gonna hit the circuit breaker, but even before then, like when it does to the LED downstream or anything like that, and then inrush hits it.
It's not hitting the LED. Well, it hits the LED.
Yeah.
Yeah, but the LED doesn't care. Because even at 10 or 12 cycles, the LED doesn't care, right? Because it's not sustained long enough to damage the LED. I mean, you really have to be switching it a lot in order to have that inrush hurt the LED. Solid state chip, right?
Yeah.
And most of them, even though we drive with 350 or 700 milliamps, most of them are designed to handle a full amp and a half. The chip really doesn't care how much inrush it sees. It doesn't care how much sustained current it sees. It cares how much inrush it sees and what the duration of that inrush is.
Yeah.
But most of the time, it's shallow enough. It's a 1.5, 1 cycle, 1.5. Even 10 or 12 cycles, not that big a deal to the chip. Bigger deal to the circuit breaker and the wire.
Yeah.
Interesting. Thank you, Keith. I think that was great. Yeah, thank you.
Controls D201. That's
Do you guys have any questions for Keith? Any comments? Okay, thank you, Keith. I appreciate it. Thanks.